If boats are so heavy, how do they float? If planes are so heavy, how do they fly? Let's find out. Welcome to Science at 6 with Cambridge Science Centre. My name is Mario and this week's presenter in the centre. I hope you all had a great week and enjoyed our ocean-themed activities and games. You can find out where to get our activities in the description below, and you can email us your results and questions to openupscience@cambridgesciencecentre.org or via social media. Last week, we asked you to try the Plankton Challenge as part of our Oceans theme. The Plankton Challenge is all about buoyancy and whether an object floats or sinks. So we're going to give it a go and using a selection of objects, various sizes and shapes and weights, and see what happens. All you need is a large container with water so you can see whether they can sink or float. I'm going to test out this piece of wood. Floats. Our paperclip sinks. Oh, our bead floats as well. Little bit of bubble wrap, that also floats. But if you combine them in many, many different ways, we can create objects or creatures that may float at the top, sink to the bottom, or possibly even sit in the middle or go down really, really slowly. So here's one I made earlier. Let's see how well this one gets on. Watch it. If we continue to watch it, it slowly sinks to the bottom of our container. How about this one? This one has a lot more paper clips, a few more wooden stirrers on it, even some beads. Let's see how this one fares in our water. That one will float just below the surface. Amazing! You may remember our Cartesian diver that I demonstrated in last week's Science at 6 programme, that when I squeeze it, you can see here it goes again, starts to sink, release, it rises back to the surface. The interesting physics behind these demonstrations is also applies to what happened here. If an object is put in a body of water and is more dense than water, it will sink. If it's less dense, it will float. And that's exactly what we can see happening here. And what's density again? Density is the amount of mass per unit volume. If an object has a lot of mass packed into a small area, it's going to be quite dense. So, do boats need to be more or less dense than water? Less dense, of course, but how does something that seems so heavy manage to float above the surface? Although the metal the boat is made from, the cargo and the people on the boat might be denser than water, but the boat is made to hold a lot of air within its hull, giving a lower average density overall, and that's what allows it to float. It might sound odd, but fish have to think about density too. Most bony fish have an organ called a swim bladder, which allows them to float and sink. The swim bladder is full of gas and has a flexible wall. If the fish wants to dive downwards, it simply squeezes the wall of its swim bladder, lowering its density, and it does the reverse to allow it to float again. We can split the ocean into zones based on how deep you go, and the ocean can get very, very deep. And the further you get down, the weirder the sea life gets, like giant squid, for instance. Check out the video in the description to find out a little more about the creepy looking fish and other organisms that live really deep down. Let's now join Katy and take a look at some of the questions that you sent in to us.
Hi, my name is Katy and I'm going to be answering a question from Sophia, age 7, who asked, why is the sea salty? Now this is a great question, Sophia, and it all begins with the water cycle. This is the way water moves around our planet from the sea to the sky to the land, then back to the sea. When the sun heats the water in the sea, it changes into water vapour, a gas, and into the air. This is a process called evaporation. When the water cools in the air, it turns back into liquid water. This is condensation, and then eventually this water will fall from the clouds. This is precipitation, and it could be as rain, snow, sleet, or hail. When this falls onto the land, the water will then flow from the land into the rivers and streams and then back to the sea. The sun will heat the seawater and the cycle continues. However, the sea is salty because when water is in the air, carbon dioxide, a gas, dissolves into the rainwater, making it slightly acidic, although not enough to hurt us, so don't worry. But when this falls onto rocks, because it is slightly acidic, it can erode, break down the rocks and release mineral salts into the water. Tiny bits of the minerals from the rocks, called ions, are carried with the rainwater into rivers and streams. Two of these minerals are sodium and chloride, which you may have heard of before. That's right, they are the ions in salt. These are carried along rivers and streams into the sea. But you may have heard before that rivers aren't salty, but how can that be true? Well, rivers are in fact a little bit salty, but it is such a tiny amount when compared to the sea that they don't really seem like they're salty at all. But the sea is, as all the rivers and streams will empty into the sea, bringing that salt with them. Do you remember the cycle I mentioned earlier? Well, during evaporation, water turns into a gas, but the salt stays behind, making the sea saltier. However, since this salt is always moving from the land to the sea, and also evaporation is removing the water but leaving the salt behind, you might think that the sea is getting a lot saltier. But actually some of this salt is removed by algae and animals that live in the sea, and some is deposited as sediment at the bottom of the ocean, and some can move around to other locations. I hope this answers your question, Sophia. Thank you very much for sending it in. And don't forget to send in any questions you have about our weekly topic, and we may answer it this time next week.
Keep sending us your results and questions to openupscience@cambridgesciencecentre.org or via our social media channels. Onwards and upwards. Now for something a little bit different. Check out this amazing demonstration of something called Bernoullis Principle with our friend Joe.
Hello, my name is Joanne and I'm one of the science communicators here at Cambridge Science Centre. Have you ever wondered how birds and planes fly? Well, today we're going to show you something called Bernoullis Principle, which plays a big part in how planes and birds stay in the air. To demonstrate Bernoullis Principle, you'll need a flat surface, like a table. You'll also need 2 cans and 2 straws or pencils. First, take the 2 cans and place them on the table in front of you so they're about 2.5 centimetres apart. We're going to take a deep breath in and blow down the middle of the cans. Watch carefully what happens. The cans roll and move in opposite directions. Is that what you expected to happen? Let's do something a little bit different. Take 2 straws or pencils and place them parallel to each other on your flat surface. Then we're going to put our cans on top of the straws, again roughly 2.5 centimetres apart. And we're going to do the same thing again and blow in between the straws. What do you think is going to happen this time? Let's have a look. Wow, that's amazing! Did you notice that this time the cans moved towards each other? But why did that happen? Well, when the cans were just on the table, all of the air was being trapped in the middle of the cans. So when we blew between the cans, we were increasing the air pressure in the middle, and that air pressure was building up until it became greater than the air pressure on the outside of the cans. When we raised the cans using the straws and repeated our test, the air was able to escape from between the cans and move faster. Bernoullis' principle, which we mentioned earlier, states that a fluid moving fast creates low pressure and a fluid moving slowly creates a higher pressure. Air also behaves like a fluid. When we blew between the cans on the straws, we were reducing the pressure between the cans. High pressure moves towards low pressure, and the pressure forced the cans together. This is the same as the wings of a bird or a plane. As the air passes over the top of their wings, the air moves faster, reducing the pressure. And high pressure moves towards low pressure, like our cans moving towards each other. This results in an upward force known as lift, which moves our bird or planes upwards. I hope you now know a little bit more about one force that helps us with flight.
Awesome. Thank you, Joe. Pretty crazy how the cans move towards each other, right? Almost as crazy as the fact that something as big and as heavy as an airplane can soar through the sky. But, as Joe mentioned, the fact that planes and animals can fly comes back to the physics of Bernoullis Principle. So, you may have been on a plane, but what is it actually like to fly one, I wonder? Well, Millie was very lucky to talk to Dominic Brown, who is a pilot for our expert interview this week. So let's find out more.
Hello, Dom. Thank you for joining me.
No problem.
Could you introduce yourself and tell us a little bit about what you do?
My name's Dominic Brown. I'm a senior first officer.
And what happens during an average day for you?
Well, on an average day, I turn up to my airport about an hour before our flight is supposed to depart. We'll go through all our paperwork. For us, it's all about our flight plans. Then we need to check over the aeroplane, make sure that we are ready to fly. So we have two pilots always on board. One's the captain and one's the first officer. We'll then divide the jobs into who is the pilot flying and who is the pilot monitoring. The pilot flying will be responsible for flying the aeroplane. They get to do the fun bit and control the aeroplane. The pilot monitoring, it's their job just to make sure that everything's going smoothly and help out the pilot flying with any extra workload that they might have. Once we've been cleared by air traffic control, a big tug will push back the aeroplane. If ever you see any airplanes at airports, if there's a big stocky looking truck that's attached normally via a bar to the front of an airplane, that's for the purposes of pushing it back, because in an airplane we have no reverse gear. Once we push back, the tug will disconnect and disappear off, and we'll start up our engines and we're ready to taxi off. Hopefully, fairly quickly, air traffic control will clear us for takeoff, so we'll taxi to the runway, line up and take off. Once we're airborne, we'll get the gear up, so you'll see all the wheels on all the big airplanes certainly will be retractable. So at some point we'll retract that. That gets rid of all the drag, so the air pushes against the aeroplane. So we want to get those wheels away as soon as possible. Once we've done that, at some point the pilot flying will engage the autopilot. We'll keep climbing all the way up, typically to around 36 to 39,000 feet. When we get close to our destination, that's when we have to start preparing for our approach. Normally, roughly around 2,000 feet, maybe a little bit earlier if it's a nice day and workload permits, we'll take the autopilot out. At that point, that's the really fun bit for us. We then fly the runway all the way down to the runway where we touch down. At some suitable point, we'll brake the aeroplane and then we'll exit off the runway, and air traffic control will tell us where to taxi so that we can go and park. Normally, on our average working day, we'll either work 2 or 4 flights.
Okay, thank you. What subjects did you enjoy at school?
I always enjoyed the sciences. I like maths and physics. I went to university and studied physics after school, but that's not necessary to do my job. You don't need a degree.
Okay, and does everyone in your role have the same background as you?
No, get many varied backgrounds for our roles. Sometimes you have people who've had aviation almost in their blood, you know. Sometimes mum and dad have been a pilot or cabin crew, and that's all that you want to do when you grow up. For me, I'm the first in my family to go into aviation at all. Nobody else was a pilot in my family. I've just always wanted to do it since I was a little boy. And
finally, name someone who inspires you and why.
Of course, the classic answer for any pilot is the great Chuck Yeager. He was the first man to officially break the sound barrier, and he's someone also from very humble beginnings and a humble background who really worked his way up through the ranks. He consistently displayed, despite all these experimental aircraft and quite dangerous situations, some fantastic qualities that all pilots aspire to be.
Great. Thank you very much, Dom.
Excellent. Thank you, Millie and Dom. That was great. So, is it a bird? Is it a plane? No, it's our theme for the week, flight. Not Superman, I'm afraid. Our challenge this week is to make and test your very own paper airplane. Did you know the furthest flight by a paper airplane was 69.14 meters by John Collins and Joe Ayub? Think you could top that? Then let us know. Send us your questions and your pictures of the work that you've been doing, and we'll take a look at some of them on next week's show on Science at 6. So thanks for flying by. See you next week.